Hello, this is Mr. Stansbury. I'm going to take you through some of the problems from the 10J assignment. Okay, first one. A goalkeeper has a probability of 3 out of 10 of saving a penalty attempt. How many penalties would he expect to save from 90 attempts? So we're simply going to take the 3/10, multiply that by 90 because he's expected to save 3 out of every 10 times 90 total attempts. Is going to give us what, 270 out of 10, which would simply give us 27 saves is what the goalkeeper could expect. Okay. Number 4, excuse me, if 2 coins are tossed, what's the chance that they both fall heads? Now, you can do this a couple different ways. You can say, well, the probability of getting heads is 0.5, and you could multiply that by another 0.5. But honestly, I think it's going to be a little bit nicer, and it's going to help us possibly better understand it with a tree diagram. So, first toss, we can either get heads or we could get tails, right? And that is 0.5 chance we'll get heads, 0.5 chance that we'll get tails. So this is the first coin. Or the first toss, or the first, it says 2 coins are tossed, so first coin. Now, let's say the first coin ends up heads. On the second coin, it could still end up to be heads or tails. And then, same thing, if the first coin is tails, the second coin can end up with heads or with tails as well. And these are also both 0.5 for all of these here, right? Oops, 0.5. So now with this, if 2 coins are tossed, what's the chance that they both fall heads? So that would be heads, heads. That's going to be this group right here. So that's going to be 0.5 times 0.5, which is 0.25. So that's the probability, 0.25 or 25%. Okay. If the 2 coins are tossed 200 times, on how many occasions would you expect them both to fall heads? So we know that it's supposed to both fall heads 25% of the time. So we're simply going to take 0.25, multiply that by the 200 times that you're going to toss the coin, and that is going to end up giving us 50 times. 50 times out of the 200, we should expect them to both be heads. Okay? All right. Last one is number 7. 7 has part A and part B. I'm just going to do part A so that you can at least have a good idea of what's going on, and I'm going to let you figure out part B. All right. Number 7. In a pre-election poll, residents indicated their voting intentions. The number of voters that favored each candidate A, B, and C were shown alongside. Okay. Estimate the probability that a randomly chosen voter in the electorate will vote for A. So over here we have 165 would vote for A, 87 would vote for B, 48 would vote for C. What is really important is we need to know what the total is for all of these. Okay, so we got to add those things all up. All right, and so we will do that. Add 165 to 87 to 48, and we get a grand total of there are 300 total people that were polled. Okay, so estimate the probability of a randomly chosen voter in electorate will vote for A would be 165 out of the 300. Okay, which gives us 165 divided by 300 gives us 55%, 0.55. Okay, for B would be 87 out of 300. Excuse me. So that's going to be 87 divided by 300, and that gives us 29%. And then C would be 48 out of the 300. So we could actually take 55 and 29, add those up, subtract it from 100, or we can just do 48 divided by 300, and that will give us, try that again, 48 divided by 300 will give us 0.16. So that would mean 16% of the time. Okay? All right, that is about half of the problems from the 10J. If you have any further questions, please feel free to ask. Thanks.